Hello everyone. So I'm going to show you the encrypt and decrypting messages data in Python. Now there are two types of encryption, which is symmetric and asymmetric. Now symmetric uses only one key to encrypt and decrypt. Now it is not secure and not that practical because it only uses one key. Alright? And meanwhile for the asymmetric, it uses public key for encrypting and private key for decrypting. Now, now I'm going to show you the symmetric. Now, I'm gonna use Jupyter Notebook for this one because I want to show you, alright, I want to run the code one by one, like block by block. So in here, before we're going to code the symmetric, we're gonna install some prerequisites, which is the cryptography. We're going to install cryptography here, and then we're gonna install it. Now I'm putting exclamation mark here, referring that we're gonna run this on a terminal. Just gonna wait. There. Now it's done. We're already done installing cryptography here. Now I'm going to import something in the cryptography library. No, wrong setting. In cryptography Fernet. We're gonna import the Fernet class. We're gonna import the Fernet class. Now, we use the Fernet class to generate key and also to encrypt and decrypt at the same time. Now, first is we're gonna make the key. Now we're gonna make a key object here, Fernet dot generate. So this is a built-in function in the Fernet class where it generates random key. And after that, we're going to instantiate the Fernet class with the key in it. So we're going to instantiate it, anything, you can name as you want. And then Fernet, this is the instantiation, and just put the key inside of it. So we have now a key to encrypt and decrypt. Now, how we're going to use it? Now, let's have an example here. So original data equals to anything. So we're gonna put the username and password. Alright, just an example. So what kind of username? So it would be like swordmaster, swordmaster. That's strange name. 123, something like that. And then our password would be like um yo 1 2 3 4 5 6, something like that. Now this is my username and password. Now we're going to encrypt this with the kernel. Now here's what we're gonna do now. Let's put this, alright, let's put this in a variable, encrypted data. Now we're gonna use the instantiation, we're gonna use the object and then call the function called encrypt. Okay, this is a function fernet, and then we're gonna, inside of this function, we're gonna put the original data here. Now, this is not done yet because we're gonna add another function in the original data. Now in Python, there's a built-in function in the string called encode. Now what does it do? It converts the string into a byte so that in that way the encrypt can modify its contents. Alright? So we're gonna put encode there. And now we're done here. We're gonna print. Let's just see what it looks like. basa na ng tawag guys. Encrypted data. If we run this, there. So this is the encrypted data from this string. Now, how we're gonna decrypt the data? Now, let's put this on a again in a variable, and again decrypted data, and again we're gonna use the object and then call a function called decrypt function. And inside of this function, we're gonna put our encrypted, not the original message, alright? The encrypted data. Encrypted data. And outside of this is we're going to have a decode function. Now, what does decode function do? Now, it's the opposite of encode. Now, since decrypt is just, full of bytes, right? It's in bytes. Now, decode turns that byte into a string, alright? So it's just like the opposite of encode, right? It turns the bytes into string. So we're gonna print this decrypted data there. And if we run this, let's check it. If we run this, you can see that it's the same with the original data. Here we have it. That is the symmetric encryption and decryption. Now we're going to do the asymmetric. Sorry for for this new because I guess my connection was lost and I have to restart again. So I'm going to install RSA. Now RSA is used for asymmetric encryption, right? It generates public and private keys. Just wait. Alright, we're done installing. We're gonna import our RSA here. And after that, we're going to generate the public and private key using RSA. We can do this in one line. Private equals to RSA dot new key. Now, this is a function. Now, inside of this function, we're going to set up our size, to handle the RSA for encryption and decryption. Now, for testing and for testing and practicing, you can just put there 512. It means 500. You can handle 512 bytes of data. It can handle 512 bytes for encrypting and decrypting. Now, it's only good for testing, but when you use it for your application, for practical use, and for production, you need to put there 2048 or higher than that. So yeah, and after that, we're going to make a original data, and here we're gonna put our username here, and then the password there, like that, and we're going to encrypt it. And we're gonna put this on a variable, alright, and then we're gonna call the RSA and the function with it, encrypt. Now this is the same with the kernel, but the difference is that this encrypt function in the RSA has two arguments, which is the original data or the message or the string. But again, we're gonna put this on an encode function, right? We're gonna you know uh, convert the string into a byte, and then the second argument is the key, which is the public key. Now, public key is used for encrypting. Now, it will not work or it will not encrypt this string without the public key, right? You cannot um, encrypt a certain string or message or data without the public key. Now, we're gonna print this encrypted data there, here. So this is your encrypted data. You can see. Now, now this is the encrypted data. Now we're going to decrypt the data. Now we're gonna put this on a variable. We're gonna call the RSA and then the decrypt function. Now, same with the encrypt, you need to put two arguments there. That is the encrypted data, okay, not the original data, and then the private key. And then we're gonna decode this because it returns a byte. So we're gonna use the decode function to you know to you know from bytes to string. All right, from bytes to string, it will convert the bytes to string. After that, we're going to print the decrypted data. That's it. If you run this, you can see it is the same with the original data. And also reminding that you cannot decrypt the data without the private key. Alright? Now if you try to put public here, alright, you cannot also decrypt it because public and private key are not the same. Right? This is why asymmetric is really secure. And that is how you code uh, asymmetric. Now this is how you code, this is how you encrypt and decrypt using Python, using this, the symmetric and asymmetric. Thank you guys.